So yeah, what I thought I'd do is just go over things for about 20 minutes, 25 minutes or so, and then we have questions and some breakout discussions after that. I'm going to put in the chat, there's some links in my talk, just so you have them there, because I probably won't put them in while I'm doing things that you can click on. The main website for all this is quantum2025.org. So if you just Google quantum in 2025, you'll find all the information you need. And that website is currently being revised. There'll be a new sort of very public-facing version, which should launch the beginning of January. But a lot of relevant information is on there right now. So let me go to my presentation. You can see that okay? Okay. So at first I thought to give some background on the international years, this particular international year in general, and kind of tell you the origin story for where this came from, just so you get a sort of a bearing on what happened. So I came to this because I do a lot of work with the history forum of APS. So I was chairing the history forum multiple years ago. And in the history forum, one game you play is you kind of think about various things that have happened in history that you think are important to foreground in physics. And you look for nice round numbers of anniversaries that are occurring, right? So it's like 40 years since this, 30 years since that. You do a session at the APS March or April meeting on that, things like that. So I knew one fact, which is that 1925 is where historians usually date the beginning of quantum mechanics, to some papers by Heisenberg. And I saw on the horizon that, oh, coming up sometime in the future, this is back in 2018, is 2025, right? And so I was like, well, that's a nice round number. And in terms of the importance of what the thing we're celebrating, like I could imagine few things that were more important than quantum mechanics to the physical sciences. So I thought we should do something rather big for this. And I think one of the things that I knew when I started talking to other people about it, which is that the word quantum is sort of floating around, and what it means to the general public is one thing, but to people who understand the physical sciences and physicists in particular, we understand all these different things. So it's 100th birthday party for quantum. We understand all these different things that quantum has affected over the past 100 years. And these are not good sort of breaking news stories necessarily. Things are developed over the course of years and decades and stuff like that. And so what we're trying to create is basically an event where we're foregrounding all the things from the past 100 years, and as you'll see, we can go beyond that, that quantum has enabled us to understand, enabled us to do, all the things it's doing, potentially doing at the present, all the things it could do in the future. The working title for this is actually the Quantum Century Project, which is sort of thinking about this whole 100 years, not so much like what happened in 1925. So I really encourage you in thinking about the quantum stories that you might want to tell or might want to foreground, to think very expansively, not just about some particular thing at this moment or some particular thing in 1925, but really across quantum writ large. And that's a lot of what I'll be talking about today. So since a few physicists knew this, we started talking about, we think that the public should know more about quantum. We think there's a lot of confusion out there about the word quantum. We think there's a lot of people who've heard the word, but don't really understand what it means. And there's a lot of people who haven't even heard the word quantum and have no understanding of how important and how central it's been. So we started having sort of more meetings that we drew in more and more people from around the world. And we came up with a set of guiding principles for people working on this project. And it's one of the links I put into the chat. But there are things like no one owns quantum science, right? So there's sometimes people using quantum as like, I have this product and this product is quantum and other things are not quantum. But nobody owns quantum science, it's something we can spread around the world. Everyone should be invited. We should recognize consensus, but honor the dissent in places, and particularly admit ignorance when we don't know certain things. One of the main goals for the year is to help other people find reliable quantum information. So I guess next month there'll be more discussions of information, disinformation, and it's really up to us as a community, particularly in this area where there's a word floating around that primarily gets used to fill plot holes in science fiction movies, for us to be able to talk a little bit more about the reality of quantum, what it actually means in our everyday lives, and what it could mean in the future. Model the ideals of scientific conduct. So I think that that the idea of behind inquiry and free inquiry and be able to ask questions and being able to take criticism, things like that is something that we wanted to foreground. Being honest, I think one of the things that concerned a lot of people was hype around quantum, and they didn't think that hype was helpful in the long run. So we should be really honest about like, yeah, there's this particular thing on the horizon which might happen, but it's not certain, and not to overpromise things. And then of course the last one was have fun, right? It's a birthday party, it's a celebration. So I really encourage you to take this general idea and make it your own. Do something that you are excited about doing, that you're excited about doing with other people. So after sort of discussions internationally among a bunch of people, we started to go into organizations. So the APS was really one of the first to get on board behind this, along with the German Physical Society. And then we started getting more and more scientific societies around the world on board. And this is just a partial list. Again, the website, you can find a full list, who said, yeah, we want to use the year 2025 to help the world celebrate quantum and help people around the world learn more about quantum. And then after you get all these organizations together, then the next step is to go to countries. So nation
Oh,
states, you have to
sorry,
convince.
quick question. Are you moving slides? Because we are only seeing
Oh,
the
okay.
intro slide.
Oh, okay. Sorry. Okay. So sorry. So you didn't see any of the things I was talking about. So we were talking about 100 years of quantum mechanics and having a birthday party. You're talking about all the different things that quantum affects. These are the visuals according to that. And these are the guiding principles I was just talking about. So I was reading through things that you weren't seeing. Apologies. So you can find these on the website. So this was the sort of guiding principles. And then these are the organizations around the world who started to get behind this, beginning with the APS. And as they're just getting to, after you get a bunch of scientific organizations around the world on board, then you start going to countries. And the particular countries, you have to basically lobby at UNESCO and the United Nations to get countries to get behind a resolution to proclaim an international year. So that was a long process. We got a sort of endorsement from UNESCO in 2023. All right, apologies again. So eventually leading into the United Nations. So on June 7th of this year, the UN General Assembly met. The nation of Ghana with a lead sponsor. There were 72 co-sponsoring countries behind this resolution. It is the only time in the 75-year history of the UN, as far as I can tell, that the General Assembly discussed quantum in any way. So to give you a sort of sense of like, we understand how important quantum is, but nobody has taken the time to talk about it. There's a YouTube video up if you want to actually watch the 6 or 7 minutes, which the UN deliberated and discussed this. But it was basically passed by unanimous resolution. So all the countries around the world agreed to it, but 72 countries co-sponsored resolution. They represent about 5 billion people around the world, right? So what does this mean? Well, the UN has a proclamation, a resolution they passed. They designate UNESCO to be the lead arm of the UN to deal with this. But the main thing is, if you look at the text of the resolution, they tell you how to celebrate IYQ. So one thing they say is that the General Assembly recommends that this year should be observed through activities at all levels aimed at increasing public awareness of the importance of quantum science and applications. So that's the main thrust is we want to use this year to help people around the world understand more about quantum. But they also stress that the cost of all activities should be met from voluntary contributions. So they do not deploy some funds or some individuals to go out and help with this. And that is the sort of main point behind this, which is that we have spent all these years kind of building things up, right? From individuals to societies to nation states to every nation of the world, right? And now we have to go back down to the public level. While there are sort of high-level events that will happen, there's a big opening ceremonies in Paris. There are some global events that are being organized. The real celebration this year comes from individuals around the world helping to create events, to create resources, to help other people understand more about quantum, right? So we need to get back down to the individual level. And so for my money, while this is all meant to be very impressive, like you have every country in the world agree on this, none of that matters unless we have individuals doing things at the ground level, right? That the UN declaration is just a signal a useful signal that has enabled everybody around the world to coordinate on a common theme for the year. And you have the whole year to plan and do something, but we want to take place during 2025. So this is why the people in this meeting are actually the more important than the nation state, which gives speeches at the General Assembly. It's really about the people on the ground doing these things. So that's the question that I bring to you, which is like, what will you do for the International Year of Quantum, that is IYQ? So when you figure out what you will do, what you want to do, when you have an event or you have a resource, there's a link there. You can go submit that to the website, and we will help to publicize that. Will be something available to the public where they can find resources or events in their area, resources that talk about this or that to help them understand more about quantum. So, and basically the rest of my presentation is just to give you a few different ideas about things you might think about. And then we'll move to actual discussion, because people may already have good ideas themselves. You may already be planning something. You may just have started to think about this sort of thing. I would also say this doesn't necessarily need to be something that you need to do on your own. Just facilitating things is really important. So I think in a lot of, in academic research environments, there are research groups with a PI who maybe is not so interested in doing this themselves. But can that PI give the student or students that work for them some space to do this, right? Can they take a day and say, hey, on this day or for this time period, can you guys do something about this? Because I think this is important, but I'm not so skilled at doing it myself. So the more we can facilitate, the more events we have. The more events we have, the more people around the world learn. The more people around the world learn, the more successful the year is. Right? And I think the more high-profile things get, the more people will start to ask questions of like, oh, I hear it's 100 years of quantum. Like, what are you doing? What is going on, right? And we would really have to get to that space where more and more people are sort of asking questions and trying to find resources. And what we want to do at the website is that it's a conduit for people finding these events and resources. So just in talking to a lot of people and thinking about this challenge of sort of quantum outreach in particular, I wanted to make a few points. So one is that nowadays, when the word quantum gets used, it's very often used in the area of what I'd call quantum information technology. So people talk about there is some coming quantum technology, right? And that's an exciting story. It's maybe a story you want to tell, maybe a story people are interested in. But I just want to remind you that while a quantum computer operates according to the principles of quantum mechanics, a regular computer that you're using right now also has plenty of quantum in it. We would not be able to build this computer without our understanding of quantum. And a lot of people don't understand that, right? From the transistors inside of here that's doing the processing to the screen emitting light and how it emits light, like our quantum understanding was really important to that. So don't limit yourself just to thinking about this type of thing. Think about other things, right? The other challenge I see a lot of people get into is trying to identify what is quantum and isn't quantum. Like, oh, one computer is quantum and one computer is not quantum, right? And so I would recommend thinking not just about like, okay, what is quantum, what isn't quantum, but what does quantum help with, right? So, quantum is about a theory, right? It's not a thing, but the theory helps with understanding how do you make a regular computer, right? And if you move to not quantum is the whole of the thing, it's not like everything in this computer needed an understanding of quantum to build, but some of the things in here needed quantum to build and were important steps. And not everybody who built the computer needed to know about those things. But if you start asking those, why does this work? Why does this work? Why does this work? Questions, you usually run across a quantum answer. And trying to make people see that there is these underlying quantum stories behind many different things is, I think, one of the goals of the year. So, another example I was thinking about, people point to lasers and they say, well, lasers are quantum, right? Because quantum mechanics was developed, people had quantum understanding, and they used that understanding to build a laser. But thinking about another technology like radio, right? Radio was invented before quantum came along, right? For those who don't know about the history of radio, one of the early types of radios was called a crystal radio. And the crystal they used is a particular material called galena. And the way that it worked is they needed a rectifier, a current rectifier, to get a radio receiver to work. And people discovered in the 19th century that there was this crystal where if you attached a wire to it and just put a little wire on top of it, that it would rectify current. And that was a key component to a lot of early radios. Now, they had no understanding why this worked. They just knew there was this rock, and this rock had this property, and it was useful for building things. This got replaced eventually by vacuum tubes, but it came back around again in understanding that what was going on there is people were forming these PN junction diodes, right? And now we have a better understanding of exactly what was going on. And we can actually make those, right, deliberately, rather than just finding a rock that has these essentially magic properties. And we use the solid state physics knowledge we have, which was built on quantum, to make modern transistor radios, to make modern rectifiers, to make cell phone receivers, all these things, right? So it wasn't that the technology only came after quantum, is that quantum helps, right? It helped to make these technologies better. It helped to make them more powerful, improve them in certain ways, to make them cheaper, et cetera. I was thinking a little bit about the sort of existing technologies and how far back I could go with technologies. So this is one of the farthest places I can go back, which is bronze, right? So bronze is one of the oldest technologies that we have, right? We have a whole age spanning thousands of years. It's called the Bronze Age. And we don't think about quantum and bronze as being related at all. But what is bronze? The most common way of making bronze was to take two soft metals, copper and tin, and you mix them together, you melt them together, and you form this really hard metal, right? And people have been doing this for thousands of years. And it is a natural question to ask, why is it? How is it that when you melt together two soft metals, you get this hard metal out, right? And while there may have been theories before our present age, like the answer to that question, our best answer to this question involves things about understanding how electrons bond to each other, right? Stuff like metallic bonding, right? So it's not that bronze and technology like needed quantum mechanics before it existed. It's that we now understand something about existing technologies we didn't understand before. And because we have a more deeper understanding, that we are enabled to be able to make better technologies, better materials, better types of bronzes we couldn't do before. So I think one of the challenges here is that sometimes we want to teach people about quantum, right? And that's great. It's a challenge, right? This is not necessarily a year where everybody's going to learn quantum mechanics. It's more about understanding it's relevant, right? Just the story of, hey, materials and the way that materials bond together has something to do with quantum mechanics, and that's relevant for why bronze is hard, right? Is one story you can tell without having to go into any technical detail about, some quantum mechanical picture over here. So it's okay just to tell that story, right? Just to say, look, quantum is important for this sort of thing. And it can definitely be the case that you don't understand the full quantum story, right? All these things have a lot of details in them, right? They're all challenging. And so it isn't, I think we sometimes get in the situation where we feel like we need to fully understand something before we explain it to somebody else. So you can explain that quantum is relevant to this without having a full understanding of metallic bonding or density functional theory or all these things, right? If you have a little bit more understanding of someone else, of, quantum is important for this, or here's my limit of understanding of a particular quantum story, that's very helpful, right? And people can connect with that. I think one of the things that can happen in doing outreach and education is that you get into a situation that you think it's like a classroom where you say, okay, I am here to try to teach you something technical. And the person who's listening to you is saying, okay, I'm about to hear something technical. And there's on both sides, there could be a sense of nervousness about this. Like, do I as a teacher really understand these technical details enough to be able to teach this? And on the audience member side, do I as a person, am I going to understand what's going on? You can always move this to your limits of your own understanding, right? To thinking about, here is my story of what I understand. Here's why I find something interesting. When people give talks at my institution, we always have them start with, what's your origin story? Like, why are you interested in what you do? And that part of the talk is there's no nervousness involved, right? The person knows about themselves. They know the limits of what they know and don't know. They know what they care about. And the audience understands them on a human level. And they can say, oh, this person cares about quantum, and we see why they care about quantum without understanding necessarily any of the details. So it doesn't have to be a technical thing. It has to be a story. The other thing that people do is, and related to that, is things versus people. So a lot of what I talked about technology, it's about things, but stories about individuals, including yourself, are very relatable. So don't forget to think about telling those types of stories if you think that those are interesting to tell. A last class of things is on the technology, science, and nature side. So when people hear the word quantum, they very often go towards that technology side of things, and they think less about the nature side of things. So in the same way that there are technologies which have existed for thousands of years, that the science of quantum mechanics has helped us a better understanding with, there's also natural things that have existed for thousands and millions and billions of years that quantum science has helped us to understand. And that's another important story to tell, because when people hear quantum now, they very often just think about technology. They don't understand that the natural world has quantum in it, and we understand the natural world more deeply because we understand something about quantum mechanics. So one example I sometimes like to use is that everybody knows that if there's water falling from the sky, if you go outside, that water falls in little drops, right? You can see those drops, you can feel those drops. Hundreds of hit your skin every second. But few people know that when you go outside in the sun and you feel the sun warming you, that the sun also comes in drops, right? In little light quanta. And that there's roughly 1,000,000,000,000,000 light quanta hitting your skin every second, right? It's something that's been happening for ever since humanity existed, but we have a deeper understanding of it now. It's a simple story. It doesn't require a lot of technical background, but it tells you a little bit more about the quantum aspect of nature. And because we have that understanding that there exists light quanta, now we can make things like solar panels, right? Which we couldn't make before. The other area that I think people sometimes get trapped in is the sort of large and small. So quantum having something to do with the small and being associated with the small, like that's an important story. But starting from everyday things or starting from very large things, you can do that. So one sort of contemporary science thing is this, recent discovery of galaxies, the earliest galaxies in the universe by the James Webb Space Telescope, right? So that's a story that got reported earlier this year. They'll probably find, more and more of these pushing the timeline back. And there's nothing in those stories about quantum, right? They'll just say, we have a telescope. We're seeing these really, really distant galaxies that began just after the universe began. But if you think about it, how does this work? Well, we need a telescope to detect these, also a big object. And in that telescope, the working part of it is some detector. And that detector needs to be able to count individual light quanta, individual photons. For discovering this galaxy, you had to count, I think, about 8 photons per second, right? If we didn't understand that light came in quanta, right, we wouldn't be able to build these detectors, and we wouldn't be able to see these galaxies that are, 13.5 billion years old. So I think one of the challenges, one of the sort of surprising things I found is just sort of thinking about the place that quantum exists in our society. So I have a little dialogue here. Here's the whole dialogue, which is you can imagine the alien coming to our universe, coming to our to Earth, and it's a friendly alien, hopefully, and asking us, like, what's our best theory about the rules of the universe, right? The physical world. And I think our starting answer is usually quantum mechanics. We might say general relativity as well, but quantum mechanics is probably the first answer we give. And the alien said, oh, I see you actually spend many years educating your young. How many years do you spend people educating about this theory you have about the universe? And our default answer is 0. We don't spend any time doing this, right? In the entire K through 12 curriculum, it might happen sometimes, but in general, the word quantum might not be mentioned at all. And that's a very surprising thing. So thinking about why that is an interesting question. Like, why don't we talk about quantum more? Why is it hard to talk about quantum? I like to use an example, the analogy of DNA, right? So DNA is also something which was discovered over the past 100 years. And it's something where the general public has some understanding of it, right? You don't need to be a microbiologist to understand DNA. And people have an understanding that, oh, underlying natural things, there's this thing called DNA. There's a picture in their mind, and that is important for understanding why biological things have the property they have. It might be seen as, oh, it's important to crime investigations. Oh, it's important to tracing ancestry, all these things that DNA might connect them with. It's important for maybe curing diseases, right? They don't have the similar theory about our understanding of quantum. They don't understand that not just the biological world, but the world in general has quantum underlying it. And one of the challenges, I think, is that there's nothing to point at, right? Quantum is not a thing. I very often like to start with photons because photons are light quantum, and it helps to ground what the word is. Okay, there's a thing that you can count, and it's new information you didn't know about the nature of light, but there's other ways to start the story. But I think that this is the challenge of the year, is trying to think about why it is hard to talk about quantum. And that may be the seed for an event that you want to do, right? Rather than talking about a particular aspect of quantum or trying to teach quantum, talking to people about, why is this so difficult? Why is it difficult for me to explain? Why is it difficult for you to understand? So those are kind of some preliminary thoughts, just to, I hope, get you thinking expansively about all the things you might be able to do. But now it's your turn. So the key questions are, again, what might you do for the year? What challenges you face? Like, are you worried about particular things? And how can we get around those challenges? And then questions that you have. So maybe I'll stop here, and if people have questions for me, then I can address those, and then we can do some breakout rooms where people can have a discussion.